Welcome to the Getting Started video for TopView for SQL events. Almost every running system generates some type of event log to record information, warning, error, and failure messages. Many of these systems record their events in a relational or SQL-based database. When an error or disruption occurs, you can usually find an event record in the database with details of the problem. But wouldn't it be nice if you could monitor SQL event logs and receive notification messages for significant events? We have a solution, TopView for SQL events. TopView for SQL events allows users to configure monitoring, logging, analytics, and notification of important events stored in one or more SQL-based relational databases. This video will demonstrate how to get started with TopView for SQL events by showing the initial configuration steps and a small set of features. We'll start with a discussion of TopView events to see how TopView handles event generators like SQL events. We'll then discuss the configuration of the SQL event generator, which involves the creation of a query against the SQL-based event log. We'll create event tags to define which events are of interest to TopView, and lastly, we'll configure the TopView engine to monitor our events tags and send email notification for specific events. TopView Events is a version of TopView alarm and notification software that supports event-based monitoring. TopView Events is designed to handle multiple event generators such as OPC alarm and events and SQL event logs through a standard framework. With TopView Events, users can configure which type of events should be monitored, display the events as they occur, trigger TopView alarms based on new events or properties of new events, configure actions and notifications for the TopView alarms such as email, SMS, and voice callout, and store and view logs of all received events. Let's start by defining some of the terms used by TopView events. An event may include an action, status, or alarm. Examples include events telling you that a door was opened or the printer is out of paper. An event generator is TopView's name for a producer of events. SQL Events is an event generator. An event source is the creator of an event. For the example event, the printer is out of paper, the source may be the administration department laser printer. Each event contains properties or fields that describe the details of the event. These properties include the source name, an event timestamp, and additional fields unique to the event generator. An events tag identifies a specific type or category of events that can be monitored by TopView. Each events tag is defined by an event generator and an event filter. An example events tag could be created to monitor all printer out of paper alarms from the South Campus. To see how these items interact, let's look at an overview of TopView events from event sources to real-time monitoring. On the left, various sources create events which are aggregated in an event generator. For SQL events, the events created by each source are written to a relational database, and the SQL event generator then reads these events from the database and sends them to TopView. The event generator delivers the details of each event to TopView, including a source name, an event time, and a list of event fields that describe other details of the event. The events tag is the glue between TopView and the events. Each events tag defines a category of events that are of interest to the user. Some of the arriving events will be used while others may be discarded. The events tag maps the event source and timestamp and allows the user to customize the row value which is used to monitor event state in TopView. A single events tag can receive events from multiple sources. The TopView engine will create a slot or row for each unique source that appears in the events tag, allowing users to view and track event state per source. These concepts are presented generically because TopView Events was created to work with many different event generators, including SQL events. As we move on to a demonstration of TopView for SQL events, the concepts in this overview will become clearer as we apply them to real SQL events. Our SQL Events demo will use a SQL database that tracks temperature and humidity alarms for 10 devices. In our SQL database, we can receive 4 possible events per device: temperature alarm when active, temperature alarm when inactive, humidity alarm when active, and humidity alarm when inactive. In our example database, the newest events are at the bottom of the table. By examining the event records, we can determine the current state of each device and alarm type. For example, looking at device 1 events, we can see that there was a recent temperature alarm from 10:03 until 10:30. Also, a humidity alarm went active at 10:45 and is still active. I now have the current state of the temperature and humidity alarms for device 1, and I can repeat this analysis for the other 9 devices to determine current alarm state. This process is what happens in TopView for SQL events. It continuously monitors the database for new events and tracks the current state of each event type. TopView then lets you monitor the current state, log and analyze state changes, and send notification for state changes. Our database is a table in SQL Server named Event Log that contains temperature and humidity alarms for the 10 devices. Each event includes the device ID, the type of alarm, the alarm state, and the time of the event. In addition, each event record contains the serial number of the device and its location. All of these fields can be used by TopView to provide information to users about event details. TopView for SQL events communicates to the SQL databases using ODBC. ODBC is a vendor-neutral open standard API for accessing databases. If you have an ODBC driver for your database, you should be able to use it with TopView. For this demo, I've configured an ODBC system data source named Device Events. Within TopView, I will use this ODBC source name when specifying the database I want to connect to and query. Before I start the demo, I want to quickly discuss the SQL statements we will use to query events. TopView for SQL events requires 2 field names in the returned query, source and event time. Each database query will, by default, return field names based on the column names in the table. My event log table contains a device ID and time of event column, and you can see in the first query that the returned field names match the column names. Part of writing your SQL query for TopView is deciding which field or fields will be your source and event time. In the second query, I've assigned the name source to my device ID column and the name event time to my time of event column. And you can see that the return fields now include the required source and event time field names. A TopView engine is a running process that performs real-time tasks such as monitoring and notification. A TopView engine can run interactively or as a Windows service. Each instance of the TopView engine is controlled by a separate configuration. The TopView configurator, seen here, is used to create these configurations. Before we create a configuration in TopView engine for SQL events, we need to configure the event generator and events tags. To do this, start the TopView configurator. In the upper right corner, make sure that the data source is events. From the left menu, select Tags and Limits, and at the top of the Tags and Limits screen, click Configure TopView Events. The TopView Events configuration screen allows the user to create and edit event generators and create or edit events tags. In TopView for SQL events, each event generator is a user-created query. Since we do not have any queries, we do not have any event generators. Therefore, the first step is to create a query for our device alarms. To create a new query, click Create New Event Generator, SQL Events Query. TopView installs a simulator for the device events database that we use in this video. You can launch the simulator from the Help menu at the top of the query configuration screen. I'll create a query named Device Query to return device alarm events from my database. Before I edit the query details, I need to select the ODBC data source. The main property of a query is the SQL statement that selects events from the database. When a new query is created, TopView will set the SQL statement to an example select statement. To edit the query, click the Edit button. You can edit the displayed select statement or click the pencil button to open a larger editor. The example select statement we include for new queries is a select statement that will return records from the device events in our event log table. You will need to change the query to reflect your table and column names. We also include some comments at the end of the example to explain the requirements of the select statement. In addition to the required source and event time fields, which we discussed earlier, the select statement must include a where clause for a timestamp field in your query results. The where clause must include a placeholder named search start, shown in red, which TopView will replace with an actual timestamp when the query is executed. TopView uses this placeholder to ensure that only new or recent records are returned when the query executes. Once you've entered a select statement, you can test it to verify that it will return recent event records. I'll execute the query for the last 10 minutes. When the test query executes, the fields list in the upper right was populated with a list of fields returned in the query results. In addition to source and event time, TopView can display and send in notification messages any of the fields returned by the query. Therefore, make sure your select statement returns any fields of interest. The query configuration screen lets you run a real-time event viewer that will display new events for your query as they arrive. This viewer performs the same real-time query functions as the TopView engine. Assuming that new events are arriving in your database, this is an easy method to confirm that your SQL select statement is configured correctly. Now that we created a query, we have one event generator. The name of the event generator is SQL: and the name of the query. The next step is to create an events tag. Each events tag is a category of events from a query that we would like to monitor in TopView. Our first events tag will track the temperature alarm events for our 10 devices. To create or edit an events tag, click the Configure Events Tag button. Click New Tag to create a new events tag. And I will call this tag Temperature Alarm. The first step in the creation of an events tag is to assign an event generator to the tag. I will assign the device query event generator, which is my SQL query. Once I select an event generator, a list of the available event fields appears. These are the fields that are returned from the query's SQL select statement. The field names can be used to construct the row value for my temperature alarm events and can also be used in the event filters of this tag. The events tag source is not configurable for this event generator and is set to the source field of the query. Our query uses the device ID as the source. The event filter is used to configure which of the query events should be assigned to this tag. Let's take another look at our query. My query delivers both temperature and humidity events for alarm active and alarm inactive. The alarm type field is the value temperature or humidity. The alarm state field is the value active or inactive. I need to configure the event filter to return temperature alarm active events. I can construct the event filter by copying event fields into the filter and setting the desired value of each field. The event filter contains one or more lines. Each line defines an event field and allowed value. If needed, the allowed value can contain wildcard characters to match multiple values. If the same event field exists multiple times in the filter, the items are logically ORed. Lines with different field names are ANDed. Therefore, my event filter is alarm state is active and the alarm type is temperature. The TopView engine will track each unique source that appears for this events tag by allocating a slot or row in the TopView engine. I need to tell TopView how many sources may appear for my events tag so that the correct number of rows can be allocated. This events tag will track device temperature alarms, and I currently have 10 devices. I may be adding an additional 5 devices in the near future. If I allocate the additional space now, I won't need to make changes to TopView once the new devices are added. So to allow for the current 10 devices and the 5 future devices, I'll set my maximum sources to 15. The row value will be the displayed value of each temperature alarm in TopView. This value can be monitored in TopView, and actions and notifications can include the row value. I will use the row value to show additional information about the temperature alarm event. The row value can be a combination of event fields and static text. I'm going to construct my row value to display the alarm type, which should be temperature, the alarm state, which should be active, and the time of the event. Instead of constructing the row value here, I'll just paste in the final string. Anything outside of the braces will appear as static text, and the fields within the braces will be replaced with the field value from the event. Now that we have an events tag, we can configure the TopView engine to monitor new temperature alarms for my 10 devices. As mentioned earlier, the configurator is used to configure an instance of the TopView engine. The TopView engine performs all of the real-time tasks. I'll use the tag search button to add my temperature alarm tag to the monitored tag list. Before I can test the TopView engine, I need to save the configuration. The TopView engine can run interactively or as a Windows service. To test my temperature alarms, I'll run the TopView engine interactively by clicking the Launch button. In the TopView engine window, Values view, the default view, displays the rows allocated for my events tag. TopView allocated 15 rows because my events tag maximum source count is 15. The tag name column displays the events tag name along with an index. As new events arrive, the engine looks to see if the event source, the device ID, has been assigned a row. If not, the next available row is assigned to this device ID. The source column displays the device ID assigned to each row. After a temperature alarm has occurred for each of my 10 devices, 10 rows will have been assigned sources. As additional events occur for an existing device, they will appear in the assigned row for that device. The value column displays the row value as defined for the events tag. This includes the alarm type, the alarm state, and the event time. We've configured TopView to monitor the temperature alarm events, but we haven't configured TopView to do anything when new events arrive. I want to trigger an alarm in TopView when we receive new temperature alarm events from the query. To do this, I'll configure a new event alarm condition for my temperature tag. I can access the alarm limits of a tag by double-clicking the tag in the list, or right-clicking and selecting Alarm Limits and Notification Settings. I'll set the first alarm condition to New Event, which will trigger a TopView alarm when a new event arrives. I'll relaunch the TopView engine to verify that the temperature alarm events trigger TopView alarms. We are now triggering TopView alarms when new temperature alarm events arrive. Since my query also returns alarm inactive events, I can configure TopView alarms to return to normal when an inactive event arrives for a temperature alarm. This will allow TopView to track the current alarm state of each device temperature alarm. The inactive event is configured as part of the events tag. The inactive event filter defines the filter for temperature alarm inactive events. It will be the same as the event filter, except the alarm state will be inactive. I save the configuration, relaunch the engine, and let it run for a few minutes to allow multiple alarm active and inactive events to occur. You can see that the engine is now tracking the alarm state of each device temperature alarm. Now that we know our events tag is working for temperature alarms, I'll create an events tag for humidity alarms. The humidity alarm tag is very similar to the temperature alarm tag, so I'll start by cloning the temperature alarm tag. I'll rename the new tag, and edit the tag. The only items I need to change for the humidity tag are the event filters. The alarm type should be humidity instead of temperature. Next, I'll add the humidity tag to my configuration and set the alarm condition for the humidity tag to new event. Then I'll save the configuration and test the TopView engine. You can see in Values view that there are 15 rows for temperature and 15 rows for humidity. If I switch to Alarms view, you can see all active and inactive temperature and humidity alarms. The active alarms display the alarm duration. The default alarm message describes the alarm condition that was violated. The alarm message is also the default notification message. So I'm going to modify the default alarm message with a custom message that displays information about the device name and alarm type. To edit the alarm message, I need to return to the alarm limits screen. Each alarm limit has a custom alarm message field. I'll configure the custom message to include the device name, device location, and alarm type. To do this, I use placeholders. The full list of placeholders is available by pressing the Escape key. At the bottom of the list, I can view and copy placeholders for my query fields. The device ID is the source, and the alarm type is temperature or humidity. I can copy and paste the field placeholders into my custom alarm message. To save time, I've already created the message, and I'll paste it into the custom alarm message field. I'll check the box to only use the custom message, apply the changes, and do the same thing for the humidity tag. I'll test the TopView engine again to verify that the custom alarm message is set correctly. The alarm message is correct, so now I can configure email notification for my alarms. To configure email notification, I need to configure the outgoing email server. I'll use my global SMTP email settings and set the from address for outgoing email. Next, I'll add a recipient to the default email group. Now that I've configured my mail server, I can configure which alarm should send email notification. Again, I'll return to the alarm limits screen. I'll enable email notification for my humidity alarms. By setting the notify field for my humidity alarm to the default email group. Again, I'll launch the TopView engine to test my alarms and email notification. Each new event will trigger a TopView alarm because of the new event alarm condition. Each TopView alarm for humidity should send an email notification. We hope we've given you a good understanding of how TopView for SQL events can be used to monitor event logs stored in SQL databases. TopView for SQL events can be downloaded for free, so we invite you to try it out. TopView contains many features beyond what we covered in this video, so we hope you will investigate those features once you're monitoring your SQL-based event logs. Please contact us with any questions about TopView or any other Excel products.